गुड इवनिंग गुड इवनिंग टू वन एंड ऑल। आप सभी को नमस्कार। ऑन द बिहाफ ऑफ डिपार्टमेंट ऑफ मैकेनिकल इंजीनियरिंग KIPM कॉलेज ऑफ इंजीनियरिंग एंड टेक्नोलॉजी, I welcome you. I extend a warm and cordial welcome to all participants, distinguished speakers, esteemed guests, as we commence the fourth day of our ATAL Academy sponsored faculty development program on title Towards Sustainability: The Role of Advanced Materials in the Next Generation Engineering. The overwhelming participation and enthusiasm we witnessed on the previous day have truly set a positive tone for this program. Yesterday's session was highly insightful, enriching our understanding of sustainable technologies and innovative research approaches in supercritical carbon dioxide in solar thermal system. Today we continue this journey of learning and exploration with renewed energy and curiosity. We are privileged to have eminent resource person who will share their expertise on recent developments in sustainable materials and energy system, helping us bridge the gap between research and real world applications. I once again welcome everyone to this day of intellectual engagement and collaboration. Let us make the most of this session and continue fostering the spirit of academic excellence and innovation. So thank you and welcome to the day 4 of our faculty development program. Now before proceeding for the session 1 of this day 4 of our FDP, I would like to take a little time to share a brief introduction of our speaker for this session. It is indeed a great pleasure to introduce our overseas expert for session 7 of this faculty development program, Mr. Shyam Sundar Chaurasia sir, who is a distinguished leader and visionary in the field of chemical engineering and management in cement industry. So it gives me a great pleasure to introduce our distinguished speaker for session 7th of this faculty development program on Towards Sustainability: The Role of Advanced Material in Next Generation Engineering. Mr. Shyam Sundar Chaurasia sir is an eminent professional with an illustrious career spanning over 4 decades in the cement industry. Mr. Chaurasia sir is a chemical engineer in addition to postgraduate diploma in business administration, bringing a rare blend of technical expertise and managerial acumen. Over the past 40 years, he has served in several leadership roles, including general manager, vice president, plant head, and chief operating officer in some of the most renowned organizations in the cement sector. His professional journey includes associations with globally reputed companies such as JK Cement, Ultratech Cement, Dangto Industries, Nigeria, Andhra Cement, National Cement Company Yemen, and United Cement Kathmandu, Nepal. Mr. Chaurasia sir continues to contribute to innovations in cement manufacturing, sustainable materials, and process optimization, promoting environmentally responsible practices in construction and material industry. In today's session topic, the role of advanced material in next generation engineering, he will share his vast industrial experience and discuss how emerging materials and technologies are transferring engineering applications for a sustainable future. So let us all extend a warm welcome to Mr. Shyam Sundar Chaurasia sir and look forward to an inspiring and knowledge-enriching session ahead. Thank you once again, sir, for joining us today. And now I would like to hand over this virtual platform to you, sir, so that we can begin with your expertise in the subject matter. Thank you, sir. Thank you and welcome, sir.
Yeah, good evening to everybody.
Good evening, sir.
Thank you very much for the introduction.
My pleasure, sir. My pleasure.
And I welcome to this session to all the producer of technocrat and engineers. In fact, it's my pleasure I have been amongst them.
Welcome, sir. Welcome.
And I salute to all of you, and hope that the future engineers and technocrats, they will be the world class through your efforts, and you'll take India as a developed country by 2047.
Sir, we
So
are
I'd
delighted
like
to have you,
to
sir.
I'd like to uh, divide this particular session in three parts. First, in the first part, I'd like to give us some general talk on the advanced materials. Second part, I'd like to run through or take you to the cement world, where there are a lot of that's a building material, where a lot of development has taken place. I hope that all of you are able to see my me. Hello.
Yes, sir. Yes, sir.
Okay. So, and the third part will keep as a question answer session. Is it okay for all of you, or would you like to have make some change?
No, sir. It is fine, sir.
Okay. So first of all, we'll discuss about some general views about the advanced materials. So let me ask a question: why the world needs today the advanced materials? I'd like to share some of my experience during 80s when I had joined as a graduate engineer in the cement industry. I landed in cement industry. So at that particular time, the kiln is supposed to be the heart of the cement plant, where all the clinkerization process were taking place at the very high temperature, around 1400-1500 degrees centigrade. So during those days, every second month that plant has to be stopped for laying the ceramic material, because the kiln is nothing but a cylindrical structure, cylindrical cell, and with the steel material which cannot stand to such a high temperature. So it has to be lined with some ceramic material that's known as refractory bricks. So those material has to withstand to that temperature. So that was a very at that particular time that alumina refractories were available, and we were finding that every second month, especially in the burning June, where the temperature is the highest, that that lining was going, and we had to stop. Every cement plant has to stop within 2 to 3 months. That was the lifetime of the kiln running, cement plant running. And apart from the other stoppages, whether other downtimes, this was one of the key factors where the cement plants were not able to run more than 2 months, 3 months of time on an average. After that, there has been some innovation in the ceramic world. Ceramic, the basic refractories, basic ceramics were developed. Basic refractories were developed that were able to stand up to 1700, 1750 degrees centigrade. So that has led to enhance the life of the the refractories lining from 2 months to even a year. Today's the modern cement plants, we are stopping the plant after 6 months or 1 year of time. So because one particular reason, that the plant was at least losing 60 days in a year. So you can say almost 18%, 20% of the time. So apart from the other failures, other breakdowns were different. So that's why, that's the reason we require a, advanced materials, some research and development where the life can be enhanced, performance can be enhanced, and the energy, efficiency can be improved. So the answer is lying over here. Airspace, a lot of lot of requirements are there. A lot of properties are required where you need a material which can stand to such a high temperature. When it is crossing the atmospheric zone to non-atmospheric zone. So these advancements are required. So probably all of are agreeing that these are the requirements, future requirements where the advanced materials are needed. Now we'll come to the what categories there all advanced materials are falling. So basically we can categorize into the 4 parts. One is the noble fibers. Second is the composite materials. Third is the metamaterials, and fourth is the nanomaterials. Although the advanced materials that can be categorized into these. Or sorry, I think I am not. Next slide. Hello.
Yes, sir.
Are we?
No, sir. Next slide is not visible, sir.
Okay. Just.
Sir, please click on the right arrow of your laptop keyboard. Yes, sir.
Okay. Now I got it. That's a. Okay. I'm sorry. I was just. Yeah. So first we'll take this noble fibers. What kind of the materials are, the advanced materials are? They are the basically this three type of fibers are there. One is the organic, this is carbon based, and third is the inorganic. Organic is the plant based fibers. And the animal based fibers, like that you might have heard the Kashmiri shawl, so wool, silk, pashmina shawl. So these are the basically high quality animal based fibers. Those are the organic fibers. And second category comes at inorganic fibers, where a lot of materials are falling. There's the glass fibers, asbestos fibers, the ceramic fibers. So all those materials are falling into that inorganic. And carbon-based fibers are also the inorganic material, inorganic fibers. But carbon-based fibers, probably carbon fibers, that's not a long back invention. That was I think it was being developed it's a development in the 90s, where these materials has been carbon fibers has been invented, and of course that industrial applications that has come later even. I'll share one of the example where the carbon fibers, how pivotal role they have played, to change the engineering sectors. So I'll be coming to that point. Now, third categories are the composite materials. So let us see what are those composite materials. Basically, these are the this is a mixture of the two materials at least. When we talk of composite materials, say the one is the fiber reinforced and there is the the particle reinforced material. Particle reinforced material, we might have seen number of wood based plywoods, some wood based tiles, all those that are the particle reinforced material. Even the mud based material, that is the particle, number of different type of these materials, they are mixed together and they have got the strength or something, even I mean, can we ask a question that what were the concrete we are using day to day? That's also a composite material. Concrete, I'm talking about concrete. What are those composites? One is the gravel, other is the cement and sand. So these are the fine example of the particle reinforced materials. So there are other type of materials are also there. That translucent concrete, that's a cement plus optic fibers. This absorbent concrete that allows the water seepage through. So these are all the advanced material and used for that advanced applications or particular applications. Particle reinforced material. Another example is the car tires. You might have seen the car tires. So those car tires, this is the black carbon particles, and along with the that's a rubber. So carbon black with rubber, that makes the car tires. So these are the composite materials. And next is the metamaterials. What are the metamaterials? These are the basically synthetic materials, and sometimes they have got the negative refractory indexes. Broadly, these metamaterials we can categorize into three parts. One is which has got the electromagnetic properties. Other is the synthetic materials, like the super lenses, and third is the acoustic, which has got that acoustic properties. So if you take that electromagnetic properties, which there are some materials which can block the sensors. They are invisible and they can block the sensors. Photonic crystals, these are the electromagnetic materials. And synthetic, the super lenses, you might have seen where the invisibility are there. The people, somebody can see them. A beautiful movie has been created. I think, if I remember, that's Mr. India. I think many of us have seen that movie,
Yes, sir. Yes, sir.
So I think it can be little interactive. That's not a issue.
Yes, sir. Yes, sir.
So in that, how a person can see everybody and he is not visible by the other guys,
Yes.
So some kind of materials are being used which has got the negative refractive index. Okay, and acoustic materials, what are those? We use nowadays, you might have seen that over bridges. Over bridges, it's a passing through the the colonies. So a lot of soundproofing has to be done. Both the sides of the bridges, you have to put you have to put certain curtain which has to stop the the sound propagation. And while this is coming up, still coming up in the Indian cities, but it's very popular in the developed world. I have traveled across many countries like US and Europe, most part of the Europe, where you might have seen even that we have seen that even when the main highways are moving through, there are the walls which has got this the soundproofing properties, and the people even the government is forced to do that because they are disturbed. And you might have heard that the flights are not allowed to land in night hours. Are we aware of that? Many cities in the Europe, the flights are not allowing in the landing in the night hours, and are taking off in the night hours because of the people complain that no, it's a creating sound. So those guys are so much sensitive, but in most of our cities, the flights are almost international flights. We are more into that in the night hours. Okay, and the next category is the nanomaterials. Of course, this has got the optical and magnetic properties. So the properties, the one prerequisite of nanomaterials are that at least one dimension should be between 1 to 100 nanometer. That's a prerequisite of any nanomaterials. And where a lot of this is still a developing world, but graphene, carbon nanotubes, which has come up, and I think that for very specific purpose these things are being used. So this has been about that advanced materials, and now we'll go for the application of these advanced materials in certain areas, in certain fields. That's all of us are seeing the power demand. Every day the power demand is going up, and some because of the lifestyle of the people, because of the development, because of the population, a lot of things are happening, and the power demand are going up. So now the question is, how we are going to meet with these demands. One is through the conventional methods, where a lot of carbon emission has to be met. Carbon emission will be there, that coal source and all those. Others are the non-conventional methods, which are the source of natural, it's a natural source of energy. There's a sun and wind, of course, and some other source like the power generation from the radioactive elements. Those are there, but of course some of the hazard that has given a lesson, that a taught a lesson to the world, that okay, this is good, this is the cheapest. Even in the today's world, that's the cheapest source of electricity is the nuclear energy. Nuclear energy is the cheapest source. But some of the disasters which has taken place across the world, that has shown us the past. No, this is there, but a lot of hazard are associated with that. So many of the countries, in fact, just Germany, that is, they have totally abandoned that. No, we are not going to use this. And similarly, the because of a lot of environmental changes are taking place, so the people are also, they they are turning their face from the conventional energy source to non-conventional energy sources. This has been a lot of environmental changes that is giving, even in India this year we might have seen that cloud burst has so much devastation in our hill stations. That's a that's an early warning that is giving us. Yeah, we are seeing all those hills. They are the protector of for Indian environment, where it is giving the lot of good seasons, rainfalls, etc., etc. But it is giving a lot of, I mean, this year we have faced probably the highest cloud burst and disasters in the roads and the cities. So the environmental changes are these are nothing but the result of the environmental changes which are taking place. And so the, I mean, all those responsible citizen of the world, as a responsible citizen of the world, it's a duty for all of us to 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 invent something which is safer and and efficient for this for the future generations. So that's why this advanced materials are required today. We are able to enter into a lot of solar cells, wind energy, because of this invention of the good materials. I mean, long back, we have seen some of the cities in European world and all those, where the wind power, wind turbines has been there. I mean, in India, in the ancient world, this has been used. But because of the mostly in the coastal area, you'll find a lot of wind is there, but a lot of corrosion is there because of this the environment, corrosive environment. These materials are corroded, and then its life is very low. So that's why invention of the advanced materials are required over there for the high life, so that they can survive for a longer period. And the efficiency that are also should be there. That's why it's become viable. So if we sorry, again, fiber reinforced. Okay, sorry, gentlemen, I'm just skipping some of the slides. I'm not moving along the slides, so I'm sorry for that.
Sir, now I will remind you, sir. Okay.
Okay. Okay. So you might have seen, that earlier, what was the storage source in the batteries? Acid lead batteries, nickel hydride batteries. That has come up. That has come up long back. I mean, but I mean, we were just laughing that the invention of this nickel chromium, this battery inventor, this fellow has been awarded the Nobel Prize only the last year or last year. And it was developed long back by him, and people have been using. But surprisingly, this fellow's recognition has come up only after a long gap. So and there has been the recent development in the sodium ion batteries, because the nickel chrome batteries, all those things, this is I mean, really costly. Now we are able to have an car which has got almost most 60-70% prices that's going into the only in the battery. And every 7 years, 7 years, the car owners, car manufacturer, they are giving the warranty 7 years, 5 years, and after that you have to replace. Then another 50% of the price you have to add up. So, that's the reason we have to have some equally, efficient power storage system and at the lower prices. So affordable prices. I'll say that affordable prices. So that's how all this, nowadays inventions are going on this particular field heavily. And some of our the great business houses, I'll say the great business houses, because they are basically converted all those R&Ds to the application arena where we are able to use them. The sodium and aluminum ion batteries. So those guys, probably Tata and some other houses, they have entered into that battery manufacturers where they are going to for this recent developed batteries where the prices will slash down heavily. So we have talked about of course, the wind turbine, solar cells. Solar energy is available since ancient. But are we able to, have we been able to use this apart from taking some, the sun bath? The answer is no. We have been not able to harness those energy for the mankind. We have been, those are going as a, only part of that we are using, part of them by the plants, and rest of the things were going as a waste. But now thanks to those inventors, which has gone, who has developed these kind of materials, nanomaterials, where these are able to capture all those solar rays and convert into the electricity. So next is of course, oh, sorry, I think, yeah. Again, this how this sustainable power demand is, development of this nanomaterial, solid state electrolyte, and all those, which is converting, of course, into the from water to hydrogen, the green hydrogen, where the India has been successfully implementing. It has got that, its aim is very high to have, and the cheapest green hydrogen producer of the world. And some of the industrialists, I salute them. They take up the challenge to produce 1 kg of green hydrogen at $1. That's a fantastic challenge. These industrial houses, they are taking up, and they are converting, and thankfully they are successfully implementing it. That's giving us a hope. All of us should have a hope that we are going to achieve it, and the days are not far behind when we will be the energy sufficient nation. That's a freedom from, of course, the political freedom we have achieved in 1947, but the energy freedom and financial freedom all of us has to achieve.
Yes, sir.
where around 70-80% of our foreign exchange we are just spending
Fossil fuels, sir.
in the petroleum and other products.
Yes, sir.
So if all these projects are coming up, and I am seeing, I'm very hopeful that these these projects are coming up very fast, and our dreams are going to be realized that we will be soon become the energy exporting country.
Yes, sir.
Of course, why? I mean, now these materials, these advanced materials, look at earlier such a big batteries, uh, kgs of batteries. They were this lead based batteries. This was giving they were giving the storage for few hours, and all these batteries, these small lithium ion batteries are sodium and aluminum ion batteries. They are small in weight. But they are they are giving a higher life, higher mileage, and so they have got that because of the higher density, energy density. They can capture, they can absorb. Safety, of course, lead and batteries. There's a lot of safety issues has been there when you are transporting. Is sometime it was their acid was spilling out somewhere, that was damaging the whole thing. But when you are when you are taking these small batteries, modern batteries, though, so no issue of the safeties, more efficient, cost effective, overall energy sustainability. So all these things are there. These are the advantages where we are finding. Now we'll be uh, we'll be talking about the AI space engineering. Gentlemen, we have heard about this carbon fiber. Why I am referring this when we're the engineering students. So after that, in the primitive ways of I'm talking about 80s or 90s, in between, somewhere this carbon fiber was invented, and suddenly we are seeing some journals that this has got the strength more than steels and all those, and but its use on the major applications, of course, the minor some uh, some scientific instruments and all those maybe of little use, but the major application where it has come up, we have seen that this one company is Boeing. Boeing has utilized this to manufacture their flights. Many of their components they have introduced this carbon fiber, and the result has been that 20% of the weight reduction of the flight. Imagine if we'll talk on the industrial basis, with the some statistics, I believe around 80% of the total cost of operations for a flight is utilized as a fuel. That's going into the fuel. So fuel is taking around 80% of the total operating cost. Left is 20%. Rest are the 20% cost. So suppose the weight of the flight itself is reduced by say 20%. Then what will be the saving in the fuel? Theoretically, it should be 20% of the fuel. 20% fuel should be saved. Am I right?
Yes, sir.
Yes, somebody?
Yes, sir. Yes, sir.
Yeah. So 20% fuel should be saved. may not be 20%, I believe maybe 15% saving on the fuel cost.
Yes.
So it is because of the Dreamliner which has utilized that technology, and they have introduced the various component where the heavy components were there, but it required a lot of strength. So they have not compromised on the strength, and the end product was what desired. But they have reduced the weight by this 20%, and they claimed and they have realized also that this weight reduction is reducing the fuel cost, fuel consumption and fuel cost. So, and then carbon footprints, that is also lowered. If the 20%, if 15% fuel is reduced, it means 15% carbon footprint is reduced, right? And the total cost of operational cost, that has come down by 15%. And that is the factor. And in fact, I was very enthusiastic. I was very interested in what's going on in this particular field. So I was keeping myself with the news development on this particular issue. So this Dreamliner has become a reality, and when the booking of this was going on, so now this is booked for another almost 50 years delivery. The countries like Japan Airlines and all those, they have given the order of 180 aircraft a day. So many of the such big airlines, they have given the order. And I believe that was a single big factor where it has changed the scenario. Now there is other competitors, that Airbus, they are trying to follow up in that direction. How we can reduce that, how we can catch up that fuel efficiency. So that's we call these innovations a breakthrough. It's not a development, it's not a gradual development, it's a breakthrough where a lot of things are changing in big steps. As India is planning, we are planning, to reduce to be carbon neutral by 2070. Please correct me if somebody is remembering. Hello.
Yes, sir.
I think this is carbon neutral. India is planning for carbon neutral by 2070.
Yes, sir. Yes, sir.
And today also, the largest contribution of our power, if you look at the power chart, how much power we are producing from the which sources, right? So it's still that thermal power plant is the largest contributor of our power generation.
Yes,
right?
sir.
So it means that still the coal is the largest contributor for the energy source.
Yes, sir.
Which of course the government of India has taken a big step on that.
Yes, sir.
Now it's very difficult to get the the new license for the power plants. Of course, some of them are coming up, but the government is not promoting. It's a rather deep promoting and asking for. Gentlemen, if you can increase that power generation from the other sources. Other sources are available. A lot of land we have, a lot of hills, barren hills we have. So the people are going, and I am sure a clean technology, an efficient technology, adopting for any countryman, that's very easy. All of us today, that electric scooters, electric auto, we might have seen the whole Delhi has been changed within few years, 2 to 3 years. It has taken maximum 3, 4, 5 years. The whole Delhi scenario was changed by the autos. All those small autos, this Delhi was full of all those small autos. And now it has propagated in today's scenario, even our villages. Nobody is going with the diesel three-wheelers.
Yes, sir.
All those guys, they are putting a small
Electric vehicle, sir.
electric autos.
Yes,
And the
sir.
cost is reduced. They have also reduced the cost also. I mean,
Yes, sir.
sometime I am traveling in Gorakhpur. I am from Gorakhpur. I am staying in Gorakhpur. Sometimes certain areas are there in the Gorakhpur which is heavily crowded. So I don't prefer to go by car, because if I'm going by car, then I have to park somewhere, and then from there I have to take the auto rickshaw
Yes, sir.
where it can go. So those auto rickshaws, they are available at damn cheap prices. So that's the advantage. So what I have been saying, that yes, the things are changing, and let's be hopeful for. Now the first part of our presentation is over. So would you like to have some gap, 5 minutes gap, or would you like to
Okay, sir.
continue?
No, no, sir.
Well,
We can have 5 minutes gap.
okay. So you can have some tea, coffee,
Okay,
anything,
sir.
and we'll join after 5 minutes, right?
Okay, sir. Okay. Okay. Thank you, sir.
Okay, right.
Okay. Dear participants, we will have a break of 5 minutes. After 5 minutes, we will again resume this session. Thank you. Thank you, sir.
Okay, thank you. We are having a 5 minutes break. Yes, you can. Chance.
Good evening, sir. And
Yeah, good evening. Shall we?
good evening to all participants. Now we will again resume this session. Sir, please continue, sir.
Okay. So, so are we? I'll now this cover a little bit on the in general in the development on the cement industries. That's a I mean major building material which has been used at least since last, let's say, almost 80 years, 70, 80 years. Is it? So now I'll be talking about we'll start this session with with a recent speech where Mr. Gautam Adani, an industrialist, is a well-known industrialist. He has been delivering a address on the day of the he was called to IIT Kharagpur, and there was convocation where he was delivering a speech, and I request to all of you, if you have not seen it, then kindly look at that video. This is a wonderful video that has impressed me. I was impressed with that that particular issue where he urged to the professors of that institute and students, what he appealed to the to this distinguished community is kindly produce not a we don't want only the industry doesn't want only a knowledgeable engineers where he has got a lot of knowledge about the subjects. Now the industry wants a skilled engineers where a engineer should be able to apply that knowledge into the field. That was his urge to the education community. And of course that there's a lot of part which the industries had to play, and he has given and long-term agreement with the certain institutes where he has given the full freedom to his industries to innovate, come back, we'll give you that application field. So that kind of interactions, basically, if you look at an Indian scenario where the engineers are engineering institutions, they have got the less exposure, less interaction with the industries. That's very bad. I mean, basically, that industries and there should not be any gap. There should be more and more interaction between the industry and uh, this technical education institutions, where the student, while learning, he should get an exposure what he where he is going to apply this knowledge. I remember, I'll share my own experience when we have been doing the engineering course. There has been in the first year, there has been some, the basic civil engineering, the basic surveying and all those subjects, they were there. And we as a chemical engineers, we were feeling the, oh, what will be the use of this for us? That kind of thought gap, that was understanding gap, that was there. Where in the mechanical engineering course, there's some, first year and second year, the two subjects were there in the mechanical design, drawing design, where we are not able to correlate ourselves, what we are going to do in for these courses in the future. But when I have been, I have been elevated as a manager of a department, where a lot of the problems we are facing in our plant, and then I had to read the drawing, go through the drawings, where maybe something, that the design aspects, that you have to see the design aspects where some problems, some solution is lying. So it was very difficult for me even to read that drawing. And then I understood why these subjects are essential for the, even the specialization branches. Even to all the engineers, these subjects are required. Instrumentation and process control. We are not knowing that what correlation we are going to have in instrumentation. But when we have been, in fact, we have been to the senior positions and become the decision makers as a vice president or head of the plant, we have to take the decisions on those subjects where, there things are related to the instrumentation, where things are related to the automobiles, things are related with the, the mechanical, or the laboratories, all those things we have to take care. So there it was essential. Then we understood that, okay, the course designs, they were all right. This is fantastic. But correlation, understanding amongst the, learning engineers or the, future engineers, this was not there. And every my batchmates, they were in the same phase. It's not something unique, So now I'll be sharing with developments in the cement industries, what has taken place in the last 30-40 years. Even today, the cement has been the prime building material in construction. Agreed. This conventional cement has been the OPC, ordinary Portland cement. This particular material has been in the more demand. Okay, because this has got the this gives a lot of strength, early strength, and all those. So the people demand. Oh, okay, we'll make the make this structures fast, having the fast strength, and construction rate will be high. But later on, I'll just run through these slides to show you what the cement plants looks like. This is a typical cement plant where you see the during the night time, these pictures has been taken. Okay, this is now. I'll just give a brief about how the cement is manufactured. So that all of us after this session will have an basic knowledge about how we are making the cement. This is largest the construction material which has been using. So basically the three raw materials are there. One is the limestone, other is the iron ore should be there, and aluminous material, some aluminous material which has got that alumina source. So if you look at what are the major component which has been used for cement making, that's a calcium oxide. There are four basically the oxides. These are the four reactive oxides which combined together. With the thermal reactions, they combine together and form the basic forms of the clinker, cement clinker. We call it a clinker. That's an intermediate product which comes out of the the cement kiln. So these are the four oxides. When we talk of the calcium oxide, where from we get it? Normally the limestone is the major source. Silica oxide, yes, limestone mines, they are the major source, and some deficiencies are there. We take it from the sand or other natural materials. Iron ores in most of the the limestone mines, some irons are there, but maybe the chemical compositions are not meeting, so we have to use this iron source, some iron ores. And similarly, the alumina source for this alumina, normally the bauxite is the major source for this. But some of the aluminous clay are there, which are where the alumina is available. So basically, we have seen that these are the three major components. One is the limestone, other is the iron ore, some is the bauxite ore. So they are all the mined materials. And in some cases, some the minor availabilities are there from the some industrial sludge, where this limestone from the paper industry, from the sludge, a lot of that's a reject material from the paper industries, where this sludge is available, which has got the this lime source. So, but basically all these three mined materials, they have to pass through these processes. One is the mining, because limestone, if you will take out from the mines, you have to mine it. Iron ore, you have to mine it. Bauxite, you have to mine it. So this mining is the first process which is involved in the cement manufacturing. Then it's a mining. Then it's a crushing. All those the stones, and these are the raw materials which are available in the after mining. It's a big chunks. So they have to be crushed to a certain level. Then the grinding of those to further fine powder, and then the clinkerization. So I'll take you to one by one. It's a mining. When you go for the mining, so there are different type of mines. Some mines are at the mountain levels. Some are on the the ground level, below the ground level. But these mines, this mining has to be done by the explosive. But some mines are they are not so strong. They are the porous material. Just if you go to the this side, this coastal side of Gujarat. So their mines, you will find that porous material are there. So you don't have to put the explosive. You don't have to drills and blasting. You simply put the surface miner, scrap it, and then use it. So their surface miners are used, and then some of the the mechanical breakings are required. So these are the ways how to do the mining. These are the typical crusher. From the mines you will have from 0 to 1000 mm, 1 meter or 1.2 meter. These are the lump size where you will get after the blastings and all those. But of course, some of the mines where the surface miners are used, so they are the lesser sizes. But ultimately, they have to pass through the crusher. Crusher, that's one stage of reducing the size again. That from 1 meter you have to reduce it to 25, 30 mm, 40 mm, 50 mm, up to 70 mm. Now then, for the next operations, you have to reduce this size so that your next process should be able to take up accept that sizes. So then it comes the crushing. So where these mined materials are put in the crusher, and their output is the reduced size of 25 to 70 mm, size 02. So these are the components, where I've just shown it. You need not to one hopper, then primary crusher, and then the vibrating screen. All those things are there. This is a typical structure. Just I have shown it for how it look like. Some of you may have already visited the cement plant, but if you're not visited, that you can have a look that this looks like. But I wish that a lot of India is the cement next. I mean, world's second largest cement producer of the world. Our even one group, Aditya Birla, where I have been I have served that company for 12 years. So today they are the almost world largest single group producer of the cement. So now they are very close to reaching around 200 plus million, where all of you will be surprising and you will be proud of. That US total cement consumption for the year is 100 million, maybe 120 million, not more than that. But India's only one group have got the production capacity of 200 plus million, 250 million. So we are very close to around 600 million, 500, 600 million capacity building, and still all the groups are growing. They are making the cement most modern cement plant. If you want to look at to visit at most modern cement plant in the world, you will find India is the India or Asia is the place where you will find that most modern cement plants are there. Hello.
Yes, sir.
Are we?
Yes, sir. Yes, sir. Audible, sir. Audible, sir.
Okay. Now next is the raw material grinding. Up to now we have achieved around 50-70 mm of size, which cannot be used as a putting in the cement kilns. So it has to further reduce the size in the powder size. So these are the one of this is one of the vertical roller mill. We call it VRM, vertical roller mill. This is being used for the grinding. Of course, the other type of mills are there, which ball mill are there, vertical roller mill, roller presses are there. So we are not showing all those figures. Only some typical equipment where you should have a feel that okay, these kind of equipments are there which are reducing the sizes from 50 mm to 0 to 200 micron. So that's there. If you find that typical circuits, the hot gases are going through, and they are drying, and they are basically the drying and grinding equipment. These are the rollers which are giving a lot of pressure on that 100, maybe 150 bar pressure, 100 to 150 bar pressures. They are putting on these are the tables where these are driven by this motor. And so these are the highly efficient grinding system. So all those the raw material, raw component as I shown you that limestone, the iron ore and this one, alumina ore, they are put together, they are ground together and put into the fine powder. Now, here's the I indicated you is is this is a cement kiln. So these are the it looks like here are the Prater cyclone. You might have seen that big tower before. I have shown you here. These are the big towers, and these are the probably that these are the shallows where these are the shallows where the fine powders, ground materials they are kept, and okay, now the fine powder they are pumped over here. Either the mechanical conveyor, elevators, or the pneumatic systems, they are pumped over here. Now, here the material is traveling through this preheater. We call it preheater because it's a before entering to this is the kiln. This is kiln what you have been seeing. This is kiln and this is a cooler. This is cooler. So I'll just give a brief process about this. The material, powder material, this is entering through this. Here we are firing the coal. So here is the naturally the highest. These are the rotating kilns. Huh? Here you will find the highest temperature inside this. So kiln has got that various temperature zones. Here will be the highest temperature because flame is here. So what I that last component, these oxides, combination of oxides, this takes place over here, and then further down here the temperature is further down, and up to here this temperature comes down to even 1000 degrees centigrade. Right. Then the cold material is coming from here, and now the waste gases. Now it's a gases are traveling from here to this upside. So the material. This is another development in the later years. Earlier the cyclones were not been there. So the people were putting the nodules and long kilns of around 100, 120 meter, 150 meters has been there. But today's development around 50, 60 meters kilns, 70 meters kilns, that's the highest. That's the longest kilns they are there in the modern cement plants. And the waste gases are passing through these cyclones. Materials are coming from here, and they are traveling down, and they are having these cyclones are to have and to increase their resistance time, the resistance, the contact, to increase that contact between material and gas, waste gas. This is the waste gas from here. So it's a traveling over here. So the heat recovery is there from heat transfer is taking place from the waste gas to material. So material while coming down, traveling down, its a temperature is going up, and gases while traveling up, their temperature are going down. Okay, so that's but even with this, the material temperature here up to coming around 880 degrees centigrade or something. When it is entering the kiln, and now it's a further going down. This is inclined kiln, so it's a rotating. So because of its inclination, its material is traveling here and taking the heat from this. Flame is up to few meter, up to half of the kiln, and then hot gases are there. So it's a material is again taking the heat. Now with the heat, I'll show you how at what temperatures different combination reactions with the oxides. I told you reactive oxides, the calcium oxide, silica oxide, iron oxide, and alumina oxides. All these four basic oxides, reactive oxides are there, which we are getting from three components: basic raw material, limestone, alumina ore, and iron ore. So from these components, we are getting all these oxides. So now this, I mean, after passing through this, the all those raw material are combined together. They are going into the semi-liquid phase, and after that it's granulated in a round shape, and they are traveling further down, because we cannot handle here the temperatures of around in the semi-molten stage. So we cannot handle these materials. So therefore, this cooler is here. It's a clinker cooler. We call it clinker cooler. This downside, where the fresh air is pumped, which is again taking up the recuperating some of the heat from the clinker. It's cooling down the clinker and taking the hot gases over here, which is used for the combustion. So these are all the development in the latter stages. Earlier, these clinker coolers, they were the stationary coolers. Sorry, they were mounted on the kiln itself. So those recoveries has not been there. So nowadays, in the modern kilns, this cooler efficiency and all those, where the heat recovery is very high, and all those development has taken place in the recent years on these systems. Earlier has been around 1,000+ kilocalories we are taking. This was taking for 1 kilogram of clinker, producing 1 kilogram of clinker. But nowadays only 600-700 kilocalories that is being used for producing 1 kg of clinker. So that's the scenario. So what I am saying, that a lot of development has taken place with the that because the people have been seeing that where are the losses, major losses, so they have been attacking on those. So the clinkerization, when we call this process, which has happened which was taking place in the clinkerization, please point me out if some time constant is there.
No, sir. Sir, you may continue the lecture, sir.
Okay, if you are finding interesting, huh?
Yes, sir. Yes, sir.
Okay, so the clinkerization is basically, these are the 4 components are there. Basic reactive oxides are there, which are converting into these components: C3S, C2S, C3. Sorry, how we can drag it? Okay, if we can. No. Okay, gentlemen. So in the kiln itself is a reactions with these oxides, and the combinations reactions are taking place, and I'll show you what are the C3S, C2S, all those phases are. We call it a clinker phases. Clinker phases. There are 4 phases inside the clinker. With the thermochemical reactions are there inside the kiln. So those combinations, oxide combinations, are taking place. So I'll briefly give you that the temperature profile in which these reactions are taking place. There are certain moisture content in the raw material. So moisture content, this has to be, when you might have seen the raw material is passing through the preheater. Once it is passing through the preheater, sorry, I think pointer is passing through the. So here in the upper stage, where the temperature of the gases are lower and the material temperature is also the least. So here the moisture is evaporating from the material. So there are 2 type of moisture where the evaporations has to take place. One is the free moisture. So that goes, everybody knows that free moisture, get out of convert into the vapor at around 100 degrees centigrade. But there are combined moisture which has to be evaporated even up to 500 degrees centigrade. So those combined moisture has to also go out. Then it starts as the calcination is a process where the calcium carbonate is a up to the the grinding stage, where we might have seen this all the powder form. We have converted all the raw materials into the powder form. So up to that stage, these oxides are in the combined form. Limestone is nothing but calcium carbonate. So calcium carbonate, they are in the combined form, calcium carbonate, CaCO3. Okay. So, but we need, for the thermochemical reaction, we need this CaO, that's a calcium oxide. So the carbon dioxide has to be liberated from there, right? So this process is called that calcination. So at around 800 degrees centigrade, this calcination reaction starts. So it starts the calcination, liberating the calcium carbonate from the calcium carbonate, from the limestone, calcium carbonate, then liberate the carbon dioxide and goes as a CO. That's a reactive calcium oxide. Okay, similarly, the other components also, that alumina Al2O3 liberated from the oxides and all, and maybe some from the from the clay material. That is there the oxides, alumina and iron oxides are there. So at this particular temperatures, they are liberating and converting into the reactive oxides. So we have got basically the 4 reactive oxides which are available before entering the kiln. They are available over, for the combination reactions. So all those combination reactions is starting from here. You might have seen that 800, 900 degrees centigrade. So the formation of C2S, we call it dicalcium silicate. Dicalcium silicate. So these combination reactions place, there are 2 part of CaO combined with the 1 part of silica. So they form C2S, CaO twice SiO2. So this dicalcium silicate. So this is the first combination reactions takes place between these 2 oxides. So the dicalcium silicate. Then the next formation is between 1100 to 1200 degrees centigrade. So that's a C3 and C4AF. So this is nothing but the tricalcium aluminate, C3A. 3 part of calcium oxide combined with 1 part of Al2O3. So they are the stable compounds. Here, those are the reactive compounds. First, you see that some stable compounds are there in the form of limestone, bauxite, and iron ore. But those oxides are again, converted into reactive oxides, and now again combination reactions are taking place. So converted into the stable compounds, C4, C3A, C4AF, tetra aluminum ferrite, and C3S. That's a tricalcium silicate. It is called as a halide also. So that combination reaction takes at the highest temperature, and that highest temperature I'll take you. This is available here where the flame is there. So this particular this reactions takes place over here. Rest of the reactions are completed over here in this particular kiln. But last reactions takes place here. It requires around 1400 degrees centigrade to convert this 1400 degrees centigrade tricalcium silicate. Now these are as I have told, I have already shared that C3S, 3 parts of calcium oxide and then 1 part of this silica. So they make the C3S. So I'll just be sharing over here also. These are the highest strength imparting component which are responsible for giving the cement as a strength. Otherwise, limestone, if you crush it and put it as a it won't give you any strength. Before calcining it, before CaO and other forms, the limestone itself that won't give you any strength. So that has to convert into C3S, C2S. Here is your C2S, 2 part of calcium oxide combined with 1 part of silica, 3 part of alumina oxides, 3 part of calcium oxide combined with the one part of, so these are the stable compounds. The tricalcium aluminate. And then here's a 4 part of calcium oxide there combined with the 1 part of alumina and 1 part of iron oxide. So these are all stable components. So this is only compound, this is only part which is responsible for, this fellow is giving only the color of the cement, gray color. Gray color is by this compound. If you take out this compound, what you'll have? You'll have a white cement. You'll have white cement. So this, the white cement manufacturer, they are trying to reduce it as low as possible. See, this iron, if they are missing, take out this iron oxide, only C3A is there. So C4AF will not be formed. So that there will be only white color. So as the least is the less is the C4AF, less is the more is the brighter color.
Sir, one question, sir.
Of course, welcome.
Sir, is there any difference in binding capacity of white cement or this brown cement?
Absolutely no. You can use white cement for making your pillars.
Okay, sir. Yes, sir,
yes. That's it. There is of course there is a little high strength because of the finer quality and all those. They because that is used for the decorative purpose and all.
Yes, sir.
But there will be some change in the strength.
Okay, sir.
But of course you can use you can make your pillars with the white cement, of course, but with a maybe 50% or 100% extra cost.
Yes, sir. Thank you, sir. Thank you.
Okay. So now, gentlemen, development. The heat required for this. If we'll calculate that heat requirement for this entire combination reactions, you will find that theoretically only the 55% of the heat that was required to convert all those things, but 45% of the heat that we have been giving by the coal through flame, okay, that was getting waste. That was getting waste. So what's the efficiency in terms of the efficiency of the kiln? That's the most modern kiln. The efficiency has been hardly 55%. With all those equipment in the preheater and everything, that was that lot of construction cost was involved. But only this was efficiency. If laboratory, if you synthesize the cement clinker, only 55% energy, heat was required theoretically. Rest 45% was the loss. And what are those losses? What are those losses? So all those, the cement technocrats, cement engineers, designers, there is a big, companies, basically the cement suppliers, cement plant suppliers. One has been the FLS Denmark. Other is the KSD German, KSD. And the third is again ThyssenKrupp, that's a German company, parent company, And those three and some Onoda, Japan. So all these they have been the the major equipment supplier, plant designers and plant suppliers across the whole world. I'm talking about the whole world. The rest of the things is today some Chinese company, they have come with the copies and all those technologies. That's a different story. They have been even the KSD German company that has been owned by one Chinese company, that's acquired by. But the technological innovations and all those things that has taken place to those from those companies. So those engineers, scientists, they have been trying hard to utilize this 45%. Where has been how to reduce these losses, and the moment you are going to reduce these losses, you are going to increase your efficiencies, and the efficiencies has been, as I shared you, that has been in the refractories, that there are a lot of losses has been there, but of course, to reduce to some level by reducing the kiln size and all those, but still uh, those losses, we call it radiation losses, some dust losses, theoretical moisture and kiln exit, gas losses, cooler exit. These are radiation losses. You see, it's 8.7%. There has been radiation losses. But if you look at the major contribution of the losses are kiln exit gases, cooler exit gases, 10 plus 20 plus 10, 30%, and plus clinker losses and plus 8% here. So around major losses are lying in these three: kiln exit gases, cooler exit gases, and radiation losses. So the people have worked hard to work on these losses. All this development in the last 30 years in the cement industry which has taken place is to cut down these losses, because that's a energy cost, coal cost, and every cost that was going up. And these losses, if you that's why if you look at the cement prices, I used to share with my friends, there's only one construction material which where the prices is almost stable since last 20-25 years. What is that? That's a cement. And thanks to all those innovators, thanks to all those industrialists who has adopted this technology, new inventions, and they have been cutting down the inefficiencies to make these prices stable. Uh, Gentlemen, are we audible? Hello.
Yes, sir. Yes, sir. Audible.
Okay. So the people have been using to reduce these losses, and these losses, kill exit gases. If you look at these two losses, gas losses, a kiln and cooler, just 30%. So you might have heard about that. Uh, uh, the low temperature generator, waste heat generators, waste heat generators, they are coming up. So a lot of cement plant, they are putting those heat exchangers, and that utilize that those heats are utilized by the to produce the steam, and later on to the steam turbine, and that is power generation. So a lot of heat today in today's scenario, if you look at the cement industries, they are utilizing these waste gases, and producing almost 60-70% of the total power requirement. This is a heat requirement. So they are generating the power from those waste gases, and generating the power to 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 run their equipment, that's grinding mill, to their kiln, to crusher, all those, they require the power, a lot of powers. So they are reutilizing these powers from these waste gases. So these are making this cement industries viable, and this they are sustaining with the lower prices. Now, another beautiful you know uh, property of this cement kiln, all of you will appreciate that around 25 years back, uh, I have visited to some foreign cement plants where a lot of waste tires and all those things they are burning. And to my surprise, in one German plant, they have been using the 5-6 type of the waste fuel. Why we call it waste fuel? That's a waste derived fuels. Today, in almost every city, Indian city, if you look at Indian city scenario, you will find that lost a lot of combustible wastes are there available. They are generated and they are dumping. But thanks to the yeah, this initiative which has been taken by some of the municipalities, some of the cities, they started thinking on the pattern of Europe. Why the European cities are cleaner than Indian cities? I mean, if you look at that particular case, you'll find there's only one difference. There's single difference. One is the waste management which has been generated by the cities, that has been highly efficient in European cities or elsewhere, American cities. And the class of construction, the class of construction which is there and which is making a difference to the Indian cities and European cities. So there are only two things which are making it different world. One is the developed world, and that is the developing world or underdeveloped world. Lot of countries, underdeveloping or developing countries are there where the people focus are very less, and then some the efficient government. I'll say that efficient government are they are putting their effort to follow those lines. And the rotary cement kilns, that has got a unique property. We have seen that the cement, the temperature inside the kiln, and the preheater also even goes up to 1,000 degrees centigrade, 1,000 up to 1,400 degrees centigrade. So there has been, in fact, I have been and fortunate to visit through all those processes, all those cities, all the European cities, where we have seen that, oh, this is making a difference between the Indian cities and European cities, where a lot of garbage and dump hills are there, which is nobody is taking care. A lot of foulers are there in the cities. Only the municipal has to dump from one place to other place. But those cities where those, you cannot, even the municipality has to pay the price to dump at a place where those municipalities or some companies, they are converting into the inert material and combustible material. Inert material, that is going for the filling and all those, but the combustible materials which are going for the cement industries and all those, a lot of chemical industries, they are generating a lot of hazardous material. But those hazardous material, they have got that fantastic heat values. In fact, while working with the UltraTech cement, I have interacted with one company, one German chemical company. What's that? BASF. So that's they were generating a hazardous material, but its calorific value was 9,000 kilocalorie per kg, where our Indian coals, they have the calorific value of 4,500 kilocalories per kg, and some imported coal, they are giving around 6,000 kilocalorie per kg. So 9,000 kilocalorie per kg, but that's hazardous material. So they have been supplying to incinerators. All those hazardous material you cannot just dump here and there. So you have to, with the pollution control board, you have to take for putting into incinerator, and they have to you have to burn it. But what's a unique property this cement kiln has? It is having that absolute most suitable temperature profile, where you need not an incinerator. It's one of the best incinerator available in the world. I'll say the best incinerator available in the world. because the plastic waste, when you're firing at certain temperature, below certain temperature, burning it below 1000 degrees centigrade, 900 degrees centigrade, and all those open burning, when you are seeing in the cities, somebody is burning those plastics and papers. Plastic generates dioxins and furans. That's one of the most cancerous gas, which can cause even the cancer. So it's a cancerous gas, dioxins and furans. If it is, but when it is burnt at the elevated temperature, I'll say that elevated temperature means 1000 plus degrees centigrade. When it is burned at that, those gases are destroyed. So this cement plant, they have got that unique property. All those waste combustible material which has got the calorific value, those has to be given to the cement plants, and they can be processed properly. They can utilize their heat values, and simultaneously whatever the ash are after burning, all those material that can be absorbed in the cement, and those cements are equally good, absolutely no difference. So then what are the cements? So that's why the things are, India is also in this particular field. I'll share you some of the Indian data. You might have seen that always you might be listening. Indore has got the top city award, cleanest city award in India. Is it? But why it is getting? That's because of unique management of solid waste. Those solid waste, they are, some companies, they are separating that inert gases, inert material from the combustible material, and combustible material in turn that's going to the cement power plant or power plant, and then those materials are used over there, and rest of the inert material, they even the road transporter can take it. Instead of clay, instead of normal mitti, they can use it for the road constructions and all those. So that topic is very hard, and thanks to the government, it has come up to the radar of the high officials of the government, and now the cities are getting clean. You'll find even the city like Gorakhpur, the NTPC, they have put up. I think NTPC, they are putting up their plant over here, and they have put up a plant in Banaras also. They are converting into all these refused material, municipal waste material, into the coke, and that's a other technology. And this coke, this coal they are using to their own thermal power plant. So that's how it can convert into the sustainable environment. Gentlemen, and whatever, where you are going, where after you can expose this particular issue to your students, and I'm sure they are going to catch. They are there tomorrow. They will be engineers in some or other industries, so they will be able to utilize and propagate this particular concept, where all our Indian cities, our future cities, they will be totally clean up, and beautiful city, livable cities, where we can everybody can live with a clean air. It has got the counter current files I have shared already. Kill lines equipment with the ESP and back filters, where earlier that has been concept that, when we joined the cement industries at that point time, there has been the concept. Okay, some dust is coming from the chimney, so that's a cement plant. Cement plant is running because some dust is low. And nowadays, thanks to all those development, ESPs and back filters, all those equipment, they are highly efficient equipment which has been introduced in the cement industries, and the industrialists, they have come up with the acceptance. These are the materials, because those are the materials which were flying out. They were the pollutants. They have been the highly useful material for the cement industries. So those materials have been trapped, and now almost all the cement industry chimneys, they are clean. So if you are going in the advise, you may advise your students, gentlemen, cement industries are quite cleaner than no dust. If you'll go with the white cloth, you'll come back with the white cloth. But you have to maintain your equipments.
Sir, there is a issue, sir. Sir, can we conclude the this session till 8 p.m., sir? Sir, actually, there is a second session from after 8 p.m., sir.
Yeah, of course. I think
sorry to interrupt you, sir.
Yeah, sure. And the cement grinding, as again the clinker, that clinker is in the nodal form. So we add gypsum. Gypsum as a it work as a retarder, because the clinker is highly reactive. All those oxides are they are highly reactive. The moment it gets with the water, combined with the water, and then this immediately it solidifies. So gypsum we add for the reaction retarder, so that between water mixing and application point, there should be around 150 or 180 minutes. They should start setting. So then clinker and gypsum, we call it OPC, ordinary Portland cement. Now the development in this particular field which has taken place, as a now the OPC, ordinary Portland cement, they have been now slowly they are out from the market, and more application of the blended cement and all these PPC, Portland cement, slag cement, Pozlana, all those fly ash earlier, those fly ash from the the power plant industries, those have been they were open for lot of things. They are the pollutants. They are flying here and there. They are going into a lot of rivers. But nowadays, no. This is zero. Fly ash from the power plant, they have been 100% utilized, and they are converted into PPC, Portland, Pozlana Portland. Similarly, the slag cement. Slag, that's this is slag or the waste of the steel industries. So a lot of heaps were there for the of slag from the cement from the steel industries. Now slag is also a beautiful material, siliceous material, which can be used along with the clinker, and then the slag cement is produced. Blended cement is the limestone. Some special cements, they are in use, which are the oil well cement, sulfate resistant cement, sulfate resistant SRC, we call it SRC, where the especially is good for the coastal areas. If any of you are towards the coastal area, never use only the ordinary Portland cement for your construction. Either use all these blended cements, slag cement, SR sulfate resistant cement, we call it surface resistant cements. So all those cements, they have come up, and the acceptability through education from the industries. I mean this, and of course the government has taken some forceful decisions also, where they ask for, except for some licensing, don't give OPC to anybody. So those are the things. Those are the things which has been implemented, and now the result are, you might have seen, more durability, low carbon emission, because the moment you start blending 30%, 70% of this 60% of the slag, so that portion of the clinkerization clinker, that is reduced. So the low carbon emission and resistance to chemical and environmental attack, as I shared with the SRC, OPC, PPC, slag cement, those are all the chemical resistance and environmental attack. So whenever you are going for your construction, at least use 100% all this blended cement and educate to the society. These are the cement, they are good. Somebody said, you know, अरे फ्लाई एश का सीमेंट है भाई, ये तो सस्ता होना चाहिए. ऑफ कोर्स सस्ता भी रहता है, but that's a you know value added product which has to be used for the durability, for the you know, for the environment. From the it also good for the chemical attacks and environmental attacks also. So with all this, my presentation is over, and I feel you must be find some interesting. And if anything is there now, is a question answer. I think it's maybe only a minute or two, whatever is left out. So any one of you,
Sir, thank you, sir, for this highly insightful speech, sir. Now, dear participants, there is a question answer session for 5 minutes, and if there is any question from your side, you can kindly ask from our expert.
Good evening, sir.
good evening.
Sir, one question asked. Sir, how nanosilica improve the property of concrete?
Sorry, can you repeat back?
Sir, how nanosilica improve the properties of concrete?
See, basically this silica, if we'll use this while using making that, you know, the concrete, so
Yes,
it improves the flowability, and in turn, you know, there is a direct correlation, the water requirement versus the strength gain of the cement concrete. If the
Yes, sir.
wire this water requirement reduces, there's a inversely proportional. If you can reduce the water requirement in the concrete mix, your strength goes up drastically.
Oh.
So all these nanosilicas, they are added as a flow improver. The flowability is improved with an even less quantity of water, so the strength goes up like anything.
Okay. Thank you, sir.
Okay, what's your good name?
Azam Khan, sir.
Sorry?
Azam Khan.
Okay.
Dr. Azam Khan, sir.
Okay, Dr. Ajam. And
Sir, there are few questions from our participants. Sir, the first question is, which type of cement is better for domestic purpose, OPC or sir PPC?
never use OPC for your purpose. If you are making your own house, there's a fantastic. When I was in the I was in engineering, so my building was in making, my house was in making, so all those OPC they were using. But after completing my engineering, when I entered into the cement plant, so there was some, you know, small construction was going on. So immediately I interrupted. No. This cement is not good. So go for PPC.
Okay.
So always use the blended cement, and that's good for you know, for any construction, especially for the some of the you know, special applications where very high early strength is required. So those are the constructions, of course. Those are the constructions which has to be with the OPC along with some additives.
Yes, sir. Sir, second question is, what is the maximum life of cement, sir?
Maximum life of cement.
Yes, sir. Cement building, sir.
Normally, you know, if you are going with the you know, depending on the construction, there
Yes,
there
sir.
are a lot of things which the life of you know, building depends on. Number one is a kind of construction, how it has been done.
Yes, sir.
Because you know, that's a kind of construction material, what type of material has been used. Thirdly is the, you know, the how it has been it has been taken care of. You know, some rusting, some chemical reaction is going on in your concrete, RCC. You will find a lot of crack in your pillars and all those.
Yes, sir.
So if you are protecting from all those, so 40, 50 years is not a problem. And then there are a number of structures which has been taken care, even the 100 years are going on. So, a typical example you may see in the Bombay. I mean, during 80s, it was very popular that Bombay, a lot of buildings are collapsing, but in Calcutta there's no such incidents. What the findings has been that Calcutta has been always the slag cement belt, and Bombay has been the OPC belt. So
Yes.
that was one of the factor. Of course, I'm not saying the whole of the factor, but one of the factor was, and this was shared with me, none other than my president, Mr. Jaraman, who was a technocrat and he was well-known figure in cement industries.
Sir, participant, hello. Mr. Santoshji, you have asked some doubt. Do you have some doubt? And you want to ask from sir? Hello. Santoshji, are you there? So, our next participant, Mr. Dattatreya Tripathi. Any doubt which you want
Yes,
to
sir.
ask
Hello.
from our expert? Yes. Yes, please.
Hello, sir.
Yeah.
Sir, pranam, sir. Sir, I'm Dattatreya.
Yeah,
Sir, I have
Mr.
one doubt.
Dattatreya.
Sir, I have one doubt, sir.
Yeah.
Sir, actually, right now I'm working for sustainable material.
Mhm.
So if I go for cement replacement,
Mhm.
I want to replace the cement because cement has so much of carbon dioxide emissions. So which material should be used as per you, sir, so that it can be given same strength as like cement, except geopolymer, sir?
Of course, there's one way of going back to the ancient construction material. Of course, where the lime surki, you might have seen a lot of our ancient buildings, they have been made.
Yes, sir. Yes, sir.
Golconda Killa and all those killas, they have been made by those materials, you know.
Yes,
So,
sir.
but there also you might have seen that a lot of surki, you know.
Yes, sir.
There's,
Yes, I know,
those
sir.
materials, the calcium oxide is there.
Yes,
So
yes, sir.
there, the reactive calcium oxide, along with some natural gradient, natural elements, they have been mixed together, and they were all, you know, crushed together.
Yes, sir.
And those materials were used. But since the construction of such a huge quantity is going on, so it was not difficult to continue that process. And something has come up. Some material has come up, which is a really good, and that's how you might have seen that development of the whole world has come up like anything. And when the tar roads were not much during those times, the Germans, they make all the concrete roads. Of course, nowadays they are converting all those concrete road into the tar roads because you know, the maintenance of, you know, rebuilding of the concrete roads, that was difficult. And once they have realized that a lot of construction technology has improved, where if you are doing the paving work and a basement work of any of the roads, you'll even the concrete road, even the tar roads, they are wonderful. Their life is good. And if you have got that, you know, flow water the elimination from that road, what inclination of those roads, so that water should not stagnate on that roads. So they have got a wonderful life. And you might have seen that tar roads, construction is very, very fast.
Yes, yes, sir. Sir, my question is, sir, my second question is that, sir, we will go for normal cement, that is, suppose PPC. Then in PPC, if already flies is there, if we add then GGPS as an external part, then can it enhance the strength of this that cement?
GGPS, of course, because there's a reactive silica. Normally, the people GGPS, they are going for the improving the flowability of the material.
Yes, yes, sir.
Okay, and GGPS itself is there are a number of companies who are grinding this GGPS, and separately they are selling it. So basically, they are the good admixtures at the time of concrete stage, and they are reducing directly that water requirement for the cement concrete. So that's a if the water requirement is cement concrete is reduced, what happens that compactness of the concrete itself is very high, and once the compactness is there, there's no see any water which is going into the concrete, they are basically taking into the two. I mean, they are utilizing two part. One is the completing that the chemical hydration reaction with the clinker phases, cement phases, and other which will be out from there. And once they are going out from there, what happens? When there is a chemical reactions, then their heat is in and evolving from there. So when the concrete setting is going on, you might have seen if you look at any concrete, there will be some heat. So that's why some curing materials are required. So that's the reason. One, if you are using some blended material, where the low heat is produced, your chances of the concrete failure is very less. And once their excessive water is coming out from there, then there is a porosity is generated. So once there is no porosity, so what happens that already the concrete is in very good strength. So that way it's a playing a part. It's a good development, and
Sir,
lot of the construction guys, they are directly purchasing this GGPS.
sir, for the curing purpose, you have told us that for curing purpose, sir, water can you use super plasticizer for that?
Super
Plasticizer?
super plasticizer for the curing purpose. See, yes, I have seen a chemical that in my Nigeria assignment, I was working for the Dangote group.
Yes, sir.
And there they were not using the water curing at all. So they were mixing some chemical in the cement, and in the while making the concrete, and after that they were not using any water curing at all. That's a zero water curing. We are also surprised. But they have been using certain, one is the cement mix, concrete mix, which was generating the low heat.
Okay.
That's number one. That was their primary combination, because we are going for the almost 3.5 million into two, almost 7 million tons cement plant. Both erection was together, and one German company was the construction company. So they were using that mix, and that was absolutely zero. This water spray and all those.
So the chemical name, can you please tell us, sir? The chemical name?
I don't know. Even they didn't disclose us. Even they didn't disclose us. They were working for us. I was from the owner's side, but they didn't disclose, and they were never allowing that.
But that means, sir,
But
low
it
heat cement.
is available. It's available. If you find, you may find on the nets and all those.
Yes, yes, sir. So that means low heat cement is good for the making during concrete in the construction.
The old cement.
Low heat cement.
Yeah, of course. They were making a mix which was a low heat cement, and along with some chemical, they were spraying along with that. So that after that, no use of water curing and all.
Okay, sir. Thank you, sir. Thank you very much, sir.
Welcome.
Sir, one question is, what is the difference between hydrogen and green hydrogen, sir?
Hydrogen and green hydrogen.
Yes, sir.
Very interesting. See, hydrogen basically is a produced. It's only making a difference in its production form. There are some hydrogen which are produced by electricity. That electricity is by the thermal generated electricity, right?
Yes. Yes.
So which is already emitting some carbon.
Yes.
Responsible. So there are three categories. I think one is the gray hydrogen. I just what is the third one, which is purely on this, which is used by the electricity, which is generated by the coal power plant or something. I already that electrolytes, they are using that electricity which has been produced by the other source of, which is
Yes.
carbon emitting. The green hydrogen is purely utilizing the electricity which is by the renewable sources. Electricity
Yes,
is
sir.
generated by renewable sources, just
Yes.
like wind energy, wind turbine, or the solar. So right now, what India is following the path, that's the production of the green hydrogen, which is which are the challenges taken by at least the two big industry houses. One is the Adani and the other is Ambani. So
Yes,
they
sir.
have taken a lot of people sometimes go, oh, they are getting the free land. But when I visited to Kutch area, I mean that's not the first time I visit. I had taken roaming around that area. It's absolutely people have got talking about if you'll given the free land, take the free land, do something over here, which
Yes.
is useful. I mean, you will not go and you will not like to go and stay there. Only the government has made a road, and in between all those barren lands, they have made a road, barren land, a road, and given the access to the industrialist.
Yes.
Gentlemen go here. The same sun is there, same wind is there. Why don't
Yes.
you go and generate some electricity? And seawater is there, which is good for the for your dissociation of hydrogen.
Yes,
This
sir.
is, no need of giving a salt in the as a for the
Okay.
electrolyte. So that's everything is available at your doorstep. Use that and produce
Okay.
green hydrogen at one per kg.
Okay. Okay. Thank you, sir. Thank you, sir, for enriching our understanding about sustainable technologies and innovative research opportunities. Thank you, dear participants. It is indeed an honor to extend our heartfelt gratitude to our Honorable Mr. Sam Sundar Chaurasia, sir, our distinguished overseas expert, for delivering a deeply insightful and inspiring session on the role of advancing material in the next generation engineering. Sir, your lecture provided a comprehensive overview of how advanced materials such as fiber composites, metamaterials, and nanomaterials are revolutionizing multiple sectors, from aerospace and renewable energy to construction and cement manufacturing. Your discussion on energy efficient materials, innovations in solid state electrolytes, next generation batteries highlighted the crucial link between the material science and global sustainability. Sir, your in-depth explanation of cement manufacturing processes, clinkerization, and the development of low-carbon, high-durability blended cements offered valuable industrial insights into achieving sustainable infrastructure development. Sir, on the behalf of Department of Mechanical Engineering, KIPM College of Engineering and Technology, the organizing committee, and all FDP participants, we sincerely thank you, sir, for sharing your 4 decades of global expertise and practical wisdom. Sir, your contributions have truly enriched this faculty development program and inspired all of us to work towards a more sustainable and innovative engineering future. Thank you once again, sir.
Thank you so much. Thank you to
Thank
all
you.
of you, and hope that any time I'll be available on my either WhatsApp or the mail you can share with any of the participant on any subject. I mean related to this one, I'll be available. Thank you so much for honoring me. Thank you so much.
Sir, thank you, sir. Good night, sir.
Yeah. Thank you.
Good night, sir.
Good night.
Dear participants, thanks to the audience for your active participation in this session. We will now take a short break of 5 to 10 minutes before proceeding to the next session of our faculty development program. The upcoming session will begin shortly and promises to be equally informative and engaging. I request all the participants to kindly rejoin on time after the break so that we can continue our journey for learning without delay. The Google form of the current session has already been shared to you. So thank you